Linux hardware support.
Okay, go ahead and say that again.
A case history in Linux hardware support. And this is the MR97310A video driver. And I should give some background about myself. I'm actually a mathematician and still teaching in the university. And we just got a new department chair, and he did my first annual review this year. I mean, the first one for him, and he got on my case because I'm doing too much of this and not advising enough graduate students. So, you know, I didn't know exactly what to tell him. But, you know, I've thought of a few things since, like right after I went out the door. But if you can see this camera belongs to Tim, and it's not one of the cameras that I'm talking about, but it could be. You want to hold it up close?
That's fine, I got it.
This is a different camera. You couldn't tell it by looking, because I know at least 3 cameras with 3 different sensor chips inside that physically look just like this. In Taiwan and China, they sort of have a bunch of standard cases, and they have a bunch of standard boards with sensor and everything that they stick in the case, and then they stencil a name on it. And you can't tell one from the other by what case it was, not even what brand it is. You know, it just, that's the way they do it. They just slap them together and send them out the door. And so what I kind of specialized in was supporting these $20 cameras that you can buy at places like Walmart and buy it for the kid. Figured that we have a civil right to have them all work on Linux. So, you know, it kind of got left to me. And what usually happens is that you get the camera and you get a CD with a Windows driver on it. And if you write in somewhere and say that you're running Linux and you want help, well, they refer you to the FAQ that says they don't support Linux, if they bother to answer you at all, which they may not. One of the more celebrated cases, well, not celebrated, but infamous, that one of the drivers for one of the main developers for Gphoto, which is the Linux camera support for still cams. One of the main developers wrote a very polite letter to Canon, and he asked them for help in improving the Gphoto support for Linux for their cameras, and he got back a letter from Canon that said that we don't support Linux. And if you want help with your Canon camera in Linux, then you should go to the Gphoto project, because they have done such a wonderful job of reverse engineering our cameras.
That's amazing.
And he was one of the chief developers, and he wanted to improve this support still more, and this is the cooperation that he got from Canon. And others of these people are fly-by-night. You don't exactly know even who's making the stuff inside of them. And one of the first cameras I supported, one of those cameras, this was the old SQ905 camera, was picked up by the police in a drug raid in Amsterdam. And so somebody from the National Forensics Laboratory of the police in the Netherlands contacted me. Now, we want to dump the camera, and the Windows driver won't do that. It just says there are no pictures in it. We want to dump the memory because maybe there are still some pictures in it, and there could have been. Turned out they weren't, but he said the government of the Netherlands wrote an official letter to the camera manufacturer asking for their help, and we didn't get an answer. So this is the kind of support these things have. And in order to find out what's going on, you use things like a USB logging program. And, well, I'm getting ahead of myself. There's some discussion of that kind of thing in here. So the camera, which this isn't, or the class of cameras, these are the cameras with the MR97310A chip, which is from Mars Technologies, which it's a controller chip for a lot of USB webcams and still cameras. Typically, these are cheap things. They are dual mode, and it's like this one that you can, or maybe this one is not like that, I don't know, but you can set it either to stream as a webcam, or you can use it as a still camera and take pictures and then download them in some more or less normal fashion. And the thing you'd better not do is you'd better not leave the batteries sitting in the camera, because it's going to run them down, because the innards of the camera run on SD RAM, no flash RAM in it. So if you have pictures in the camera and remove the batteries, pictures are gone. It's typical of all these cheap ones. I mean, you know, they're really cutting corners. So the MR97310A cameras are kind of typical, mostly fairly expensive stuff. Some of them are a little bit more deluxe. And so the history of Linux support for these cameras serves well to describe the difficulties in the development of Linux hardware support, the evolving nature of the support for a rather common piece of hardware, and the involvement of several individuals over a period of time measured in years. The history also well illustrates what happens during the Linux development process, including in particular the pooling of effort and knowledge of diverse individuals, each of whom can bring forward some essential piece of the work. Technical details will be omitted except for explaining them only to the extent necessary for a general reader to follow the story, which is interesting not only in its technical aspects but also in its human aspects. And by the way, I originally wrote this for my previous boss so that he would understand what I'm doing, and he's a mathematician, specifically a topologist, and knows very little about computers. But I can, I can make it more technical. I think I can even show you some code. Okay, the MR97310A chip is the main controller chip, and now this is a thing that you have the main controller chip, and that controls this and talks to the inside of the camera and tells it what to do. It also has a connector that controls this. This is a cheap camera. It doesn't have the big LCD display that you can look at the picture. You're supposed to use a viewfinder. And so it tells you typically how many pictures are in the camera. You can cycle through a list of commands, and you can tell it that I want big pictures, small pictures, uncompressed pictures, compressed pictures, what have you, you see. And with some others of them, you can do things like get it into a certain mode where if you press this, it will delete all the pictures. Or sometimes if you press this, you can get it to delete a certain picture on the camera. It depends. I mean, they're all a little bit different. So one of the things here is that a USB device may use a standard command set, like a flash drive. They're all standard. And some devices are a standard streaming device, like this fellow on the laptop or on the camera. And some of them are proprietary. And if they are proprietary, then the way they work is the way the manufacturer fixed it to work, you know, the command set and everything. And the way that you have to discover what's going on is by plugging one into a Windows computer with the driver installed, and then you talk to the camera, you see, and you log what's going on. So the camera doesn't have any pictures in it. You know it doesn't have any pictures in it. So you go through the motions of opening the program that looks for the pictures, and it reports you have no pictures. You make a record of what happened. Well, so then you snap a photo, just point it somewhere and shoot it, anything, and repeat this process. And pretty soon you'll see a byte somewhere down there that was a 00, and now it's a 01. Well, take another picture and do this again. Aha, I'm on to something. That byte that was a 00 and now it's a 01, now it's a 02. It's counting the pictures. Because you're going to have to. You have to know, if you're going to download the pictures, you have to know how many they are. And, well, let's go on with the talk. I'm digressing, and it's in here. Okay, so we have some unknown command set, and we have to figure out what it is. And as I said, the way you do that is by logging USB traffic and conducting carefully controlled experiments, observing what the command is and what the response is. And, you know, it doesn't take long if you've done this 2 or 3 times. I mean, there's a kind of a script you can follow once you've learned it. And you can figure out what it's all doing. Okay, Mars Technologies, though, seems to be a company which is closely related with another Taiwanese company, PixArt. PixArt makes camera sensors. And when you talk to the controller chip, you are not talking to the sensor. The sensor is going to, the controller chip is going to talk to the sensor, and it's going to send along any commands. And so this is an issue that comes up here. So PixArt produces 5 slightly different sensor chips which are in common use with the controller chip, the MR97310A. And they're even worse documented than the controller chip. And so you have to figure out what's going on, again, by logging and making educated guesses. And the more you learn about this, the more you figure out which each one of these commands is doing. I don't claim to know everything. There's some other people much better at that than I am. So, but the issue comes because the sensor chips all have a different command sequence for initializing streaming. So I hope that this is interesting. I mean, this is puzzles, you know, and you have to figure them out. Okay, with the above as an overview, the support of cameras with the MR97310A chip presents an interesting case study in the development of Linux support for USB hardware which is not accompanied by readily available information about what is in it, nor about how it works. Several strands of development had to take place before these cameras could be supported as they are at present, and which I will claim is very well, seems to me, and several people have made contributions. These different aspects involved things like the following. First, problems of detecting and classifying the cameras. There are unanticipated problems. The methods outlined in the USB specifications do not suffice. More on this later. Next item, supporting the command set of the cameras, whether as still cameras or as webcams. The webcam mode commands include the commands for sensor initialization. These cameras use several sensors. They all, if you work them as still cams, they all use the identical command set because one is only speaking to the controller that then tells the memory what to do and what have you. Download this, download that, you know, turn yourself off now, we're done, you know, that kind of thing. Most webcams, including these, use data compression. Proprietary compressed formats need to be decrypted.
Yeah, that sounds like Microsoft.
Well,
Legacy there, everything changes.
oh, well, I mean, you know, very serious about this. There's a reason that compression algorithms are used in webcams. It's a very simple issue of speed. That if you have any serious size of picture, then let's suppose that you have, let's say, a 320 by 240 picture. Then how many pixels are there? Well, 320 times 240. Well, the finished picture is going to require 3 times that, which means that each pixel you have to have an ordered triple of 3 bytes, standing for red, green, and blue. How do you get this when you only downloaded 320 times 240 bytes? Well, you cheat. This is called biodemosaiking. I could have given a talk about it because I've written a biodemosaiking algorithm for still cameras. And essentially it involves cheating, you see, in order to inflate the data to 3 times its size, which is what you actually need to show a finished photo. But 320 times 240 is already plenty. And if you have a USB 1.0 device, you're not going to take many frames per second. I mean, I forget exactly what the math comes out to, but you know, the trite phrase is do the math, yeah? Because the data only moves so fast, so you've got a speed limit, and you've got this much data to download per picture, then the number of pictures per second is going to go down. And so webcams just about have to use compression. Still camera you don't need to, because how quickly you get the photo down onto your computer is not really such a crucial issue. But for a webcam,
Yeah,
they just have to go.
as possible, so
Yeah,
the appearance of motion.
yeah. Which, by the way, also makes my biodemosaic algorithm absolutely no good for a webcam because it's too slow. You know, and slow piles on slow. You know, it's good for still pictures. Okay. So, however, every time one of these manufacturers, each one of them thinks, well, I've got a better webcam compression method than the other guys over here. See? And they don't bother to tell anybody how it works. Probably not even their own programmers. I mean, you know, I had another camera, again not this, and not an MR97310A. I've seen another one that I actually went in with a disassembler. You know, looked at the assembly code. And I swear to God that I think that I have seen some of the crappiest. It's obvious what, you know, what they were coding from. That if you see a choice in switch algorithm, then that's probably what it came from in C, right? Well, not something like that. And, you know, I must say that I've absolutely seen some of the crappiest programming. I think that those people must hire undergraduates in computer science and pay them the equivalent of minimum wage in Taiwan to write these commercial camera drivers. I mean, some of that stuff, I mean, it's poor, you know. It's really poor. And makes one kind of proud of Linux, because we don't tend to do that stuff. Okay, most webcams use data compression. Oh yes, and the MR97310A cameras require external routines for adjustment and correction. You know.
Ted, I was going to say something about what you saw when you were disassembling. You know, C has, most C compilers back when I was working with them, have the ability to compile into assembly code.
Yeah.
So it kind of sounds like they were writing it in C, compiling it into assembly code,
Yeah.
just leaving the cruft in, the extra stuff.
Well, talk about cruft. I mean, it boiled down to the following. That you have a list of, I guess you call them nibbles. Is that an official word? You have 0 up to 15, yeah, 4 bits. And you have to reorder the list, okay? That 8, which is the middle, stands for 0, yeah? 9, and what's happening is that you're doing a predictor and corrector type of thing with, you have the 2 bytes over here in the picture, and you want to make the 1 here, so you take the average of the 2, yeah, and that's the predictor, and then the corrector is how much you're off, yeah, and the corrector either has to be 0 or 3, or it has to be 8 or 16, or I forget what, you know, and so it goes 8 is 0, 9 is 3, 10 is 16, yeah, like that, until you go off scale, and then goes down the other way. So you have to reorder these bytes, and every one of these bytes, or nibbles, you have to reorder them, and then every time you hit one, then it signifies, you know, this much correction, either positive or negative, yeah? Well, you know, so what they did is they put together a choice algorithm, you know, that for 8 emit 0, yeah? And for 9 emit 3, yeah? And for 10 emit, I think it was 8, yeah? 8, yes. And this is all from memory. It's been a long time since I studied that, as my students tell me, in the math courses, when they had it last semester or even last week. Okay, so 11 is 16, 12 is, I don't know, like 32. And then there are some other things you can do with it, and you know, so why not just to make 2 ordered lists, yeah? That you have the bytes, or the numbers 0 through 15 suitably reordered, yeah? And then you have the correctors suitably reordered. I mean, there's no use for an if-then or a switch and choice algorithm or nothing like that, you know? I mean, it just... And my son fancies himself as a game programmer, and he was explaining to me that how he went and took a course at the university, and they wanted him to do a choice algorithm, it's a course for beginners, and he looked at the task that they gave him. Oh, it would be so much easier. And I said, don't tell me. I said, you did it this way. And he said, well, yes. And I said, and the teacher didn't like it. He said, no. I said, that's because they have a class there and they're trying to make everybody understand what a choice algorithm is and how to write one, because they've got people there that can't. You know? Well, he didn't understand. I mean, the impatience of youth, you know? But, you know, you stop and think about it, it's pretty obvious, but they put this in a commercial product. This piece of absolute crud. I mean, you can see what under the G-Photo project.
Right, I'm just saying that there's two different ways to talk to the camera. There's the mass storage.
Mass storage and PTP, yeah. And for mass storage, you can just plug it in, and it's a standard thing. And if you want to talk to it with PTP, then it's, as I said, this is in G-Photo. Marcus Meissner is the main developer of that. He has a day job for SUSE, but he's also the leader, current leader of the project, pretty much.
PTP is a standard protocol between the Canons and the Nikons and the Pentax and the... So
yeah, well, he's the one that wrote the Linux PTP support.
Right, so that camera would have common support, and you're more talking about this camera, which has got no standard whatsoever. No,
there's no standard, nothing.
Right.
Yeah, neither is this one that Tim bought.
Back in the late 80s and 90s on PCs, there was all kinds of proprietary database systems, and I worked with a lot of them. You have to go in and just figure out how they were storing data.
Yeah.
You've got the same principle of a formatted stream, and finding where your signals are and following in and experimenting with them. Actually, I used to write bulletin boards that way too. Don't tell me that.
Yeah. Okay, so first thing is that for this camera and for others, a brief discussion of USB device detection follows. That first of all, the USB standard is a spec written by an organization, it's a consortium of hardware manufacturers and software producers. It includes Microsoft and Apple and you know, a bunch of others, and I don't know who all, probably Seagate and Western Digital and you know, just all kinds of people got together to write the spec because they essentially they wanted to get rid of the floppy. That's one thing. They thought it was too big and unwieldy and didn't carry enough data and wouldn't let you move it fast enough. And they also wanted, okay, so developed based upon a perceived need for more flexibility in connecting peripheral hardware of all sorts. USB was deliberately designed to allow these peripherals to be hooked up or removed at any time from a running computer without harming the computer or the device. I mean, these were the design objectives, and it seems that they pretty well met them. And to provide an industry-wide specification for conformant hardware. Thus, there are specifications for certain standard cables and connectors, voltages, and most important here, detection of whether a device has been plugged in and how the device must identify itself. And I guess everybody has used either looked at the proc USB devices file or has looked at the output, verbose output of LSUSB. Familiar with that? Maybe some of the others aren't.
So a way to really reliably detect what's plugged in?
Yeah. Well, what has to happen is that this all has to work. A piece of hardware which does not obey these specifications, or more realistically stated, violates these specifications flagrantly in some basic aspect, cannot be advertised and sold as a USB conformant device. and this is a misconception that a lot of people have. It has nothing to do with the operating system. It's all at the hardware level, that how this stuff is supposed to function together. Now, you do find violations now and then. And the MR97310A cameras are a borderline violation. Every computer which qualifies as USB capable must detect the attachment of a USB device, and upon doing so, it sends a standard query. Essentially, the query means, device, I see that you are there. Please identify yourself. The device must understand this query and must respond in a certain standard format. And so, for example, if you look at LSUSB verbose output, essentially what that's doing is that this is printing out in people-readable form the information which is in that data block. That everything has to be in a certain place, done a certain way. It's a very compressed format. Some of the things are simply located by position in that field, you see, and then they can be read, and everything is supplied. The operating system can then check whether or not the device is supported. That if the operating system is unfamiliar with the device, it then does nothing and the device just sits. Doesn't do any harm, but it just sits there and drains a little bit of power from the computer, and that's it. If the operating system does have support, it proceeds to implement that support. I mean, this is the way it's supposed to work. And for the most part does. One thing which must be understood at this level, again, is that this basic communication, the first step in supporting an attached USB device, must take place. The operating system on the computer and the particular nature of the device are irrelevant, provided only that it's a computer that has USB-capable hardware and USB support in the operating system, and the device is a certified USB device. This communication takes place and it can be interpreted. So, the device must respond to the standard query and provide certain standard information, and do so in a standard format. There are several important pieces of information by which the operating system identifies a USB device. Vendor and product number. There's a 4-digit vendor number, hexadecimal, 4-digit product number, hexadecimal, and this is supposed to identify the product uniquely. Of course, now, what does it mean uniquely? Very interesting question. If you put a different sensor chip in it, which requires different initialization commands. So that's one thing. The class, subclass, and protocol specification. Everybody here know this? Huh? You know.
Not so much, but a little bit.
A little bit. And what about those people that we can't, that I can't see here, that are watching through that thing? What do you think?
It's like the first 4 octets of a MAC address, where it's assigned a vendor, and then the remaining 3 octets are the actual device. So what he's talking about is the device ID and the vendor ID. So you could look at the 0, what is it, the 086. The Intel device ID is almost like a, oh, what is it? It's it's like 8086. That's what it is. 8086 is the Intel device ID, and so when you see that, or that vendor ID, when you see that vendor ID, you know that Intel made this.
What's confusing me here, though, is that the vendor ID is 4 hexadecimal digits. That's a maximum of 65,535
for the vendor. Yes.
Yeah. So
Yeah, and then the product ID.
Yeah, the product ID.
Right,
So every vendor could have 65,000 products.
right, but you could have over 65,535 vendors.
Okay, this camera, I just plugged it in.
These six
Yeah.
all over.
But a lot of times when you get the vendor ID, it won't be the vendor ID Linksys, it'll be the vendor ID Realtek.
Mhm.
Okay?
Yeah.
Because it's the device inside there, the hardware inside there. So you could have the same vendor ID of 3 different brands of things, depending on, and of course, like Realtek or TP-Link or Linksys or whatever, they could have their own vendor ID and then reprogram the micro. So there's all these ways it could happen.
Okay, well,
And
you,
it's very popular in serial devices. You can buy like an FPI RS-232 USB to serial adapter, and you can plug it in, and your device ID and vendor ID will be FTDI, and you'll go, oh, the computer will go, oh, look, it's a serial interface. But you could also buy that, and you could reprogram it with your own vendor ID, and then it could say this is a remote control for an XYZ. And under the covers, it's just serial.
yeah. Okay, so,
Which is also why in a lot of the header files for a lot of the drivers in USB and Linux, it'll give a great big list of all of the different devices that this matches, so that it knows to put this driver in when this USB device shows up. And then
Yeah.
a newer device will show up, but they won't change the protocol, and the only thing to add support to the device is add another device.
add another device number. Yes, exactly. That often happens. Yes, exactly. That often happens.
I've done it myself with like a SCSI controller, because it's the same thing with the PCI device ID. You get a brand new LSI Logic SCSI controllers, new Linux distro doesn't, or Linux distro doesn't recognize it, and you're looking at it and it's like, oh, it supports the same Fusion framework, so you go into the kernel, you add a device ID, compile the kernel,
Yeah,
change your Linux.
yeah, yeah. Well, let's see. Yeah, I was, if everybody's seen LSUSB output, I mean, anyway, can't show it to you. Just plug something in LSUSB and do the option -V and -D, and after the D, put the ID number, you know, the 4-digit vendor and product code, and then you'll see a whole detailed list of things. Yeah, so this is one, the vendor and product number. The second is the class, subclass, and protocol specification. Certain types or categories of USB devices are classified as standard, and there exist standard and publicly known methods for communicating with them. For example, mass storage. Class number 08, using the SCSI command set, subclass 06, and the bulk transport communication protocol, protocol OX50 or 80 in decimal notation. You know, and all of the pocket flash drives, practically without exception, they're that.
Mm-hmm. And good thing too, that'd be a real thing.
Well, you know what? When this was a great advance in USB support, that Windows 98 actually allowed you to give the vendor and product number, and so if you had a bog standard flash drive and plugged it in, it detected it not by class and subclass and protocol, it detected it by its ID number. And the driver CD came with the product. You remember that?
Yeah.
And then if you had another one that worked the same way and plugged it in, it wouldn't work, because it had a different product vendor and product ID number. This is how Windows was ahead of Linux at the time. Yeah.
Wrong.
Of course.
Windows would say all that extra features.
Well, I mean, of course, you know.
Those are shortcomings, those are just.
Of course, no, this was an opportunity to sell Win2K. Because, you know, they finally did it sort of right.
Well,
Sort of.
It was definitely better than Windows 98.
For that, anyway. Okay. Now, of course, there also exist completely proprietary devices. The class-subclass protocol for this is FF 255, FF, FF. And if your vendor and product number is there, and then it says that it's FF, FF, FF for class, subclass, and protocol, then if you don't know how to support that device by its ID number, you're up a tree. Could be anything. Doesn't even say what it's doing. Of course, what's funny is, what's funny is weird hardware. Been about a year or so ago that somebody discovered out in the wild a flash drive that came with a vendor product number of 0000:0000. But it did say that it was 08, 06, 50, and so you could use it. Both in Windows and in Linux, by the way. But, you know, they're not supposed to do that. That device is supposed to be pulled off the market or never have gotten there. So, okay, several other fields exist in the standard information block sent by the device in response to the standard query. At least in some of the standard classes of USB devices, the device is supposed to report a serial number and a name. But sometimes the serial number is missing. And sometimes the name, even if present, is something highly nonspecific, such as digital camera.
Yeah, see that before.
Yeah. However, sometimes such things can be used if the two standard identification methods fail. Such methods are inherently unreliable, sometimes dangerous, and partake of desperation. But they are occasionally used by some operating systems. To the best of my knowledge, Linux does not use these other methods. But I've read some of the stuff about how Windows can identify a USB device, you see, and they claim to be able to do it more often than we can. I don't know if I'd try some of the stuff that they fall back on, but they do.
Well, Windows loves broken hardware.
Oh, well, hey, we have to support it too. You want to, digression. I'll tell you a story about a camera that chip. This was a Grandtech GTA 829X chip. The X was usually a 0. And it came with an installation CD which says that it's proprietary Class 06, subclass 06 SCSI, and bulk transport, OX50. But the first letter was double F. And Grandtech apparently went broke because of this, and they were taken over by some other Taiwanese chip manufacturer. Can you guess what they did?
Probably fixing the driver.
It was a mistake that they burned into the chips before they sold them. They committed the off-by-one error.
Mm-hmm.
That the U.S., the standard USB mass storage command starts with the characters USB-C, and then a certain, whatever it is, and then there's a certain portion of this that this is the command block wrapper, and the command is a SCSI command, and it fits in a certain place. Yeah?
So they put it in the wrong bit?
No, they didn't do that. The command block wrapper is supposed to be of length 31 bytes. Mm-hmm. And I corresponded with one of the developers of this who used to frequent the Linux USB mass storage list, and I asked him why 31, and he just replied, well, because there's nothing else in a computer is 31 bytes, you know. So they very carefully counted from 0 to 31.
Right, that's so much. Off by 1 byte.
And so they sent down to the camera a command which, according to the opinion of what the camera is expecting, is 1 byte short. And so the camera is sitting there, it's still hungry, and it wants another byte before it will respond. You can freeze up a computer that way.
Oh, sure.
Well, the company that did that went broke. I mean, they received their just punishment, but this is what happens, I think, when you hire minimum wage programmers. Yeah. Okay. The only way that, well, let's see, where are we? It happens sometimes that a manufacturer puts in the market 2 or more devices which are different in internal details, which share the same USB vendor and product number. If the device is proprietary, then the only possible way to identify the device on the USB bus is by way of the vendor and product number. If you have 2 things that have the same vendor and product number, the operating system literally can't tell them apart. Consequently, if the 2 devices are not identical, and at the USB level the computer can't tell them apart, the only way that they can be distinguished from one another is for the supporting software, the driver, to be loaded, and then the driver needs to use its internal processes to do such a determination afterwards. So the driver software needs to ask for further information. This method of identification and the occasional need for it comprise somewhat of a gray area in the USB spec. Some would argue that such ought not to occur, that this is just wrong. That 2 devices which do not operate identically really ought to have different vendor product ID. And since they do not, the 2 devices are both out of conformity with the USB spec. In the real world, such does occur. And in the real world, some driver software which ought to do such a query does not. And they just rely on shipping the right CD with the right product. And sometimes they fail to do that.
Yeah. Or
Okay.
they'll ship a CD with all of them on one CD and you don't know which one to install.
Yeah. But even if all of this were done right and the correct driver version were always packaged with the correct device version, there's still the possibility that a hapless consumer might purchase 2, quote, identical, unquote, devices, which unfortunately require 2 different versions of the driver. And now this is one of those situations, see the Windows, that they solve it so well. You're screwed.
Or you could always look at it from the Apple perspective. The Apple perspective is we only support hardware that's got the Apple blessing on it,
Yeah,
and we will charge you money
for it.
to make sure that you did your job right,
Oh, yeah.
which makes Apple more expensive.
Yeah, and then,
But it also makes the Apple user experience more reliable. Because
yeah.
far and wide, you can't plug absolute junk hardware in Apple.
Okay. So the problems in the USB detection of these cameras. Okay, they're proprietary, so they have to be identified by the vendor and product number. And there are several of the cameras that use several known vendor and product numbers, but in particular, I'm going to pick on two number strings that come up with frequency. One of them is 093A, 010E, and the other one is 093A, 010F, and these are used by several cameras of several different brands. And all of the cameras function with the same driver support, basically, and you see at the USB level they're identical, and all of the still cam commands are identical. And they use the same decompression algorithm for compressed photos. The two exceptional cameras use the same command set, but also use an unknown compression algorithm because still cameras. So there are two cameras that, never mind them, still can't be made to work. Okay, but somebody needs to figure out how that particular compression algorithm works if anybody is sufficiently motivated. When used as webcams, the cameras are not identical. They are in fact not even always identical, even if they have the same vendor and product number. In particular, cameras with the number 010E do not always use the same command sequences. What will start one of them streaming may fail on a second one. And what starts the second one can similarly freeze up the first one. If one is using Windows in the OEM software, that is the end of the matter. None of the driver software detects any information about the camera other than the vendor product number. That's it. And thus, no matter what course of action the user takes, at least one of the cameras will fail to work. Maybe have two different computers. I didn't think of that, of course. I mean, they'd like to sell more Windows. It is also not possible to determine which driver code to use based upon make and model of the camera. As I said, they just stencil that on the outside, you know. Such information would have to be embedded in the standard USB information block in order to be used. I mean, that's the other thing, that it's not in the USB information block. And so if it's not there, the computer can't use it. Since this is usually
How
not...
do you find out eventually? Or we just have to go to a different camera because...
trial and error that I found a command that will distinguish them, and it is an undocumented command. It is not in the Windows driver. I did it. Of course, I had lots of these cameras that I didn't care if they caught fire. I mean, you know, they're like $10 or $20 a piece. They didn't catch fire. Okay, so one is left to infer that at least two different sensor chips may be used in different production runs, even in a given brand, make, and model, depending on market availability of the components. I mean, I think they just buy these things in job lots, you know, and just grab one off the shelf. In other words, which sensor chip was installed in a particular camera with the USB ID ending with 010E is a fact which has no correlation at all to brand, make, or model. Many cameras of nominally different make and model are in fact identical inside, and even cameras of the same make and model are not necessarily identical inside. And a similar problem exists with the 010F cameras. And in this case, there are 3 different possible initialization sequences. How do the OEM drivers for the cameras deal with the situation described above? They don't. So, we have the best support of these cameras of any operating system, because you can pick up any one of them and plug it in, and the sucker will work. And you can't guarantee that anywhere else.
Is the driver you're talking about in the mainstream kernel? Or
Yeah.
You don't have to compile as a module?
Uh,
You normally do anyway, but...
Well, it's, where's the code? Well, it's in, let's see. Okay, I have a tarball with a recent kernel here. Okay, here's Linux 3.9.5, and this is under drivers, drivers media, it should be. Think, yes, media, USB, okay, GSPCA, and GSPCA is an overarching program for webcam support, and it was originally stood for it was originally the SPCA project, because SunPlus had a sort of a, what they people thought was a quasi-standard. And so this is generalized SPCA, and then you can look at the file mr97310a.c, and there it is. And,
Okay, go ahead.
yeah,
Roll.
okay, so what we need to do is that we need to detect the cameras, and I just commented here that if one does web searches for the Windows driver for certain of these cameras, like one particularly infamous one was the Vivicam Mini.
The webcams now?
Yeah, the Vivicam Mini works as a still camera, but you will find Google is full of complaints about the driver not working for streaming. And they were really bad about sticking the wrong CD in, you see.
Maybe I had one of those.
And
Vividar webcam.
I
could never get it to work.
I have 2 of them that have different sensor chips in them.
I finally just gave up.
Well, it'll work now. Go plug it in, man. It'll work.
I gave it away.
Oh.
I gave it away a couple of years ago.
Sometimes it
How old a kernel were you running a couple of years ago?
I don't know, what was it back then? Less than 2, I think.
Oh, well.
I
It wasn't.
I don't really pay attention to the kernel anymore. I used to, when I first was into Linux, I would recompile the kernels all the time and stuff. And
Well,
that's what I've gotten
Okay.
older and lazier. So now I
Okay.
just use whatever's out there, Ubuntu
mm-hmm.
and Debian are the flavors that we run at work, so that's what I run. I was a Red Hat man for a long time,
Mm-hmm.
even owned stock in Red Hat, which has gone down tremendously in the last year and a
I
half.
remember when the IPO came out.
I've never seriously run anything but Slackware. I mean, you know,
Well, that's what I learned. My first distribution was Slackware, and was on.
I learned it. You know, I learned it. I learned how to install it. I know it like the back of my hand, my own hand in the dark. I don't see any reason to change. You know, I mean,
Not unless you need Pam.
well, what would I need that for?
Well, as soon as you still want to start doing authentication against LDAP or something, you got to start using Pam.
Yeah, well, you know, different things for different people, and the thing is that you know, as far as all of my interest, I mean, most of you are into software and net stuff and, you know, networking. And I've always just been intrigued by hardware and how it works. And so, you know, I'm quite satisfied that I know where all the working parts of the operating system are, and that makes me very happy indeed. Okay. And none of these drivers from any of these companies do any kind of a search or query or anything. And maybe if I can find in the kernel here, okay, there's a command, well, the command for camera initialization is way down here in this file. Okay, so here's all a bunch of specific stuff about sending commands to the camera and getting responses. Okay, now this one is for zeroing the pointer in the camera. Apparently I'm zeroing the memory pointer, and some of them require you to do that. Others don't care, but it doesn't hurt any of them. Stream start, stream stop. Okay, let's find the, okay, SD config, this is the function. Several of the supported CIF cameras share the same USB ID, but require different, this is CIF and VGA. CIF is the half size, you know. Require different initializations. So here we are detecting it. First thing, zero the pointer. Then give the command for starting the stream. What I think it really does is turn on the sensor. And then the initialization needs to come after that. And so then we query for the sensor type. And so we send it a certain command and we get a response back. And then we classify that. And, you know, and I'm the one that figured this out. Classify that and decide whether it's one of these or these or these, you see. And then same thing for the VGA cameras, which use the ID ending in 10F, and send it the same command and get the response back. These are all different. And then according to what we, then we have to turn the sensor off and restart it, and then send whatever is the appropriate initialization sequence.
The initialization sequence is that
for the sensor, in order to make it stream.
That's just not, this is a string of bits in order to get it to do what it needs to do.
Mm-hmm.
You're not passing firmware or anything like that.
No. You know, but it is weird. I mean, you work with this stuff, you learn all kinds of things. For example, the detection, as I said, was found out by trial and error, and weird things happen. It worked, and then I tried it on another computer with a different kind of USB onboard chips, and it doesn't work. And it happened, yeah, something like that. I mean, it just gives erratic results. And then there's something else in the initialization sequence. I think that it may have been for one of these cameras or maybe for something else, that I was doing all of my work on an Athlon system with Athlon, and I think that it had NVIDIA chips on the board. And then I had it, well, I better try it on another machine. I had an Intel dual-core Pentium 4, wouldn't work. camera wouldn't stream.
Is one of those an OHCI and the other one's an EHCI?
No, they were both UHCI.
Okay.
Intel and, no, I take it back. Maybe it was OHCI. You're right. I think the NVIDIA chips were.
They were either that or VIA.
No, these weren't VIA. I think they were NVIDIA, or is it NVIDIA or ATI? It was ATI. I think they are the ones that I think they're the ones that were bought out by you know, the
ATI was bought out by AMD, yes.
AMD. Yeah. Okay. So now, you know, I discussed here something about how you figure out what's happening. That first thing is, what's the device supposed to be doing? That, believe it or not, that helps a lot. Suppose it's a still camera. Well, what does a still camera do? It takes pictures. It stores them. You want to download them. So when you hook the computer to the camera, then it's obviously going to have to count the pictures. It's obviously going to have to tell you how large the pictures are, yeah, as far as the amount of data. And so you can start looking for traces and signs of this in a USB log, and you'll find them pretty soon, you see.
What software do you use on Windows to trace the USB?
Well, you know, that's a good question. Right now I've been using USB Snoop, but there's a problem. It doesn't work on any version of Windows beyond XP.
Fantastic.
And as far as I know, that for Windows 7 or 8, there is no decent USB logging program.
Can you use a protocol or
Well,
it's not a protocol analyzer, it's a
you mean hook it in between? Yeah. Yeah, you can do that. I've got one of those. Yeah, a USB analyzer. You can do that, or you can log it in Linux.
Now I'm thinking of the device that, I don't know why my memory escapes me. It's not an oscilloscope, but it's a logic analyzer. Can you use a logic analyzer to do that?
What's it do?
A logic analyzer just figures out what, if the pin is high or low, and you can plug it into a series of pins, and if you plug it in like a serial interface, as long as you tell the logic analyzer what the baud is, or you know what the signal, or how the clock works, or which is the clock pin, or whatever,
Yeah.
it could actually decode it all the way up to binary, and in some cases even ASCII. So if you had a decent logic analyzer plugged into a serial interface, and you had a GPS plugged in, it can decode it all the way up to the NEMA sentences.
Mm-hmm.
And I wonder if something like that would work for USB. I mean, it is.
Well, it probably would, but you have USB analyzers that capture the bytes. I mean, you can record
for that already.
Yeah, there is something that's built for that. And I think that I have one. I think the one that I've got is good for up to USB 2.0 or 2.1. But as far as the sniffing program is concerned, there are no good sniffing programs, and one of the reasons for that is that Windows claims to be, tightening up their security here, and so they claim to have an excuse. So.
Right, because that would have to be a kernel layer that couldn't be in user space.
Yeah.
And then they're doing certificate signing and all that for kernel space stuff.
Yeah. Well, there are some, but the ones that I've tried to look at are extremely frustrating because, for my purposes, what do I want? I want it simply to print out in unadorned form the bytes that come out and go, yeah? And yeah, and tell me which way they were going, and tell me that which endpoint that they were going to or from, yeah, endpoint. In Windows they call them pipes. And, you know, the rest of it really should be just plain ASCII text, including the bytes for all of the data that comes down. Because one of the things you can do if you have that data in text form is that, for example, you can convert it back into binary form. And if it's uncompressed, all you have to do is put a header on top and you've got a photo, you know? And so if somebody's going to just decide that all of this in the middle of here is redundant and I don't want to see it, I do too want to see it, you know? And put it all out in some proprietary format, you know, I'm very unhappy actually, because I don't have this problem solved.
We're getting, this is really interesting, that we're really getting close to messing with people's bedtimes here.
Yeah, okay,
Including my wife's.
okay,
Now, we don't want to mess with that.
No.
No, you don't know my wife.
okay.
I don't have
You
to
already
your
got
wife.
So,
So can you use a safely logic to do it?
I just want to mention that there's a fellow in the Netherlands that's very good at reverse engineering compression formats. And I would say that he did about 95% of the work on this camera, and then I found a little mistake that I was able to correct, and so I'm going to claim credit for the 5%. I've done some other cameras completely, but not this. And then Hans de Goede was very good at this. And let's see, anything else here? No. Application of some of the image processing. You see, we're proud of ourselves. For these cameras, where did it go? And similar raw converter programs for other cameras have led, that's another thing, that you can go to the web page of the SVN tree for Gphoto. And I have put there several autonomous decompression and processing algorithms for several cameras. You see that you can take the raw output and work on it and, you know, change the code and see if you can do something better. So if you can get the raw format out of the camera, you can try out one of these algorithms for processing it. And, you know, this is a big help to be able to do the same data and get the same pictures again and again and again and again with a little bit of tweaking.
Sure.
Yeah, okay, so,
You know what you might try for your USB sniffing?
what?
Is I was just looking here, and VMware has a USB analyzer,
Mm-hmm.
and that makes sense because if you virtualize Windows and you plug your device in and you tell VMware to map that device through to